Hello, ladies and gentlemen. Today we are going to take a look at some area formulas. So areas of triangles, parallelograms, all different types of shapes, even circles. For our notes today, you're going to need something to write with as well as that little foldable that we have there to kind of organize those formulas in. The pictures are already drawn inside of that foldable. You just need to write down the formula that corresponds with it, okay? The pictures already illustrate what the measurements are, but you need to write down the formulas. So let's start at the beginning here, talking about what it means to be area. When we're talking about area, we're talking about the space inside of a shape. It's always measured in square units, and that's because we're asking ourselves how many square units, how many literal little squares would fit inside the shape. So we would say how many of those little blue squares would fit inside this arrow. That is the area we're talking about, that many square units. So a lot of times the units are going to be given in terms of feet or inches or centimeters, but sometimes you won't have any units and you just need to put units squared there. So when we talk about area, we're talking about filling in that shape with little squares, okay? So let's go to your formula sheet now. So some of these are pretty basic ones that you've seen for a very long time and used for a very long time. So we're not going to spend too much time talking about where they come from, but let's start with the area of a square. The area of a square, as you know, a square looks like this. It has all sides that are the same. The area of a square can be found by taking the base times the height, or the length times the width you may have learned in earlier grades. Because all the sides are the same, it's the same thing as taking the base and squaring it. Because this base and this height right here are the same measurement in a square, because all the sides are the same, it's the same thing if you were to take, 5 times 5, that would be the area of a square with a side of 5. So area of a square, you can use either formula here. Sometimes you might see it as area equals side squared. That's another one you might see for area of a square. Rectangle is just a longer square here. It has a longer base and a height, so we would just do area equals base times height. Now in this case, the base and the height are not necessarily the same length because we're talking about a rectangle, but we would just take those two numbers and multiply them. Area of a parallelogram is just a slanted rectangle. Now in a parallelogram, you also have a base and a height. Now keep in mind, base and height come from the fact that if I cut off that little triangle there and I placed them on the other side over here, I would in fact have a rectangle. So with that in mind, the formula is in fact the same. Area is base times height. Now be remembering or thinking about the fact that height is straight up and down. Oops, that's a very poorly drawn straight line, but not in fact the width or the slanted part of this parallelogram, okay? Height is always straight up and down. Now, area of a triangle also kind of comes from our knowledge of rectangles and parallelograms. So let's say I have this parallelogram and we know the area is base times height. Now, if I'm talking just about a triangle, I'm going to take this parallelogram, cut them in half, throw half away, there's my triangle. So that's why we say it's base times height divided by 2, or just 1/2 of base times height, because technically it's half of a parallelogram, rectangle, square, any of those, since they all have the same formula. So these are ones that you probably have used up to this point. Now we're going to take a look at a couple more complicated ones. Let's start with the trapezoid. The trapezoid has a little bit more going on. If you remember with me, trapezoid has two parallel sides, base 1 and base 2 you see labeled here, B1 and B2. Trapezoid will also have a height like this. Now in order to find his area, the formula is a little bit more complicated, and that is mostly because this side may not be slanted in the same way this side is, but we can still use two trapezoids to kind of derive or to come up with this formula. So first let's imagine this trapezoid right here is flipped over and placed side by side next to himself, essentially. He looks like this. Okay, original trapezoid, the other one flipped over. Now I have two trapezoids side by side. Guess what I now made? That's right, it's a parallelogram, okay? And in order to find the area of a parallelogram, remember, it's base times height. So remember, the base now is what we would get if we had B1 plus B2. That's the entire base of this parallelogram. And then times the height, that would be the area of this whole gray shaded figure. But remember, my original trapezoid wasn't really two trapezoids together, it was just one. So I would take away half of this. So I would take this and multiply it by a half. or just take half of it, or divide it by 2, however you want to look at it. So the area formula for a trapezoid comes from this understanding. Here's our formula. Area of a trapezoid. We have 1/2 base 1 plus base 2 added together, and then times the height. Now, another cool way to remember this, in case this looks a little bit too complicated, a trapezoid, this expression right here, 1/2 base 1 plus base 2. Base 1 plus base 2 divided by 2 is this mid-segment in essence here. This mid-segment is 1/2 b1 plus b2 added together. That's the mid-segment. So it's like we're saying we're taking the mid-segment times the height. That's how you find the area of a trapezoid. But a lot of times you're going to see it just written as this main formula with all these different variables, and that works too. Now let's think about a kite or even a rhombus. So here's a rhombus picture. How do we come up with an area formula for this? Well, a rhombus is made up of a bunch of right triangles. And you'll notice in this picture I have labeled in dashed lines here a couple really important features. These are the diagonals. One diagonal goes all the way across like this. That's diagonal 2. The other diagonal goes up and down from corner to corner this way. And these are all little right triangles. Now, you'll notice that this base of this right triangle is really half of diagonal 2. And the other half of that second diagonal would be over here. Now, up and down, this vertical is half of diagonal 1. And this one would be half of diagonal 1. Now, if I was going to find the area of, let's say, just this triangle right here, I would do 1/2 base of that triangle, which is half of diagonal 2, times the height of that triangle, which is half of diagonal 1. And now if I simplify this expression, what I get just for the area of that one triangle is I would get 1/2 times the 1/2 times the 1/2. If I just look at all three of these 1/2 fractions here, that would give me 1/8. And then I still have diagonal 1, diagonal 2. So diagonal 1, diagonal 2. That is the area of just one of these little triangles. Now, since I have 4 identical triangles, I would take this thing times 4. 1/8 times 4 is in fact 1/2. So the formula for area of a rhombus is 1/2 diagonal 1 times diagonal 2. So let's kind of summarize that in our notes. The area of a rhombus, there's our formula. And the picture would look something like this. And we also have a kite that works in a similar way. Area of a kite, 1/2 diagonal 1, diagonal 2. And the kite would look like this as well. So for the rhombus and the kite, we're going to be focusing a lot on those diagonal measurements and using those to help us find the area. Okay, and our last figure we need to get into your little foldable is that circle. So the circle has 2 very important formulas associated with it. Notice I didn't title this area formulas because we're going to throw a circumference in here too. With circles, we're talking about the area quite a bit. The area is the space inside again, how many square units would fit inside here. But also circumference is the distance around the outside of a circle. So in essence, it's the perimeter of a circle, if a circle had sides, because perimeter just means to add up all the sides. So circumference and area both share the fact that they have pi and an r in there. Area is pi r squared, and I always remember that because it's unit squared after all for area. And then circumference is 2 pi r, or you may have learned it as pi times diameter. Both of those are okay. So we're going to be using these formulas quite a bit, and I want to thank you today for taking good notes and getting those into your foldable so we can use them from this point forward. Thank you. Kincaid out. And I'm still here because I'm going to shut this off. And still here. And